Hi everyone. Today I want to discuss about stoichiometric calculation. This stoichiometric is a Greek word. What is this? Greek word. So in Greek word, what is the stoichiometry meaning? Stoichion. Stoichion meaning what is that? Element. Metron meaning what is that? Measurement or measure. So totally stoichiometry. Somebody will pronounce stoichio, but depends. This is stoichiometry. Meaning what is that? Element measurement. So we know now stoichiometry means element measurement. Then actual meaning of this element measurement in a balanced equation is it is a quantitative relationship between reactant. This is very important. In between the reactants may be or and products. This quantitative relationship between the reactants and products, that is called a stoichiometry, that relationship between the reactant and product. Then how to calculate this stoichiometry calculation? When reactant information is given, then we have to calculate for the product, or product information may be given, then we have to calculate about the reactant. So for that I will give the a step by step points to calculate the given information to unknown information. So the rank points, it means whatever I am giving the information in the tips, that is called rank tips. So now first point is write the balanced equation from the given information. That is the first point we have to do. Second point is when necessary convert the known mass, because sometimes they may give the mass of the reactant or product, or sometimes they may give the number of entities, mean atoms or molecules or ions, like this information may given in the question of one substances, mean maybe the reactant or product, that's why one substance. Then convert into which one? Amount meaning what is that? Mole, using its molar mass. Which mass or which information is given, by using that compound molar mass we have to convert to moles. Or maybe entities given, mean use the Avogadro number and convert into moles. That is the second point. Third point is use the molar ratio in the balanced equation to calculate the unknown amount. Amount meaning what is that? Mole of the other substance. In case reactant information given, then we have to calculate product mean. So in that balanced equation we have to use the stoichiometric coefficient and convert into the unknown amount of the other substance. Or maybe product given, meaning a product stoichiometric coefficient we have to use to calculate the reactant, whatever the mass are, maybe entities. That's why keep in mind third one, what is required? Molar ratio. For that compulsory what is required? Balanced equation required. Then fourth point, when you know the molar, it means mole of the other substance, from that again we can convert into mass or number of entities by using molar mass or Avogadro number according to the given information. In case we have to calculate the other substance mass, mean use a molar mass. In case we have to calculate the number of entities, mean use a Avogadro number. So these four steps are we have to follow for the calculation. So keep in mind, first one is the balanced equation required. Then we have to convert into mole. From mole to another substance mean use a molar ratio. For that, we will get the mole. From the mole, we can convert to mass or number of entities. These are the information required. That is, briefly, I will explain here. For example, A reactant convert into B. In case information of A given mean we have to calculate the information of the B. In case B given mean information of A we have to calculate. So for that I can write here, in case mass is given, mass of substance A. So with this mass we have to convert which one? Amount. Amount meaning what is that? Mole. Mole of which one? That is amount of A. These are interconvertible by using which one? Molar mass. Capital M in molar mass. Otherwise I will write here molar mass. Which molar mass we have to use? Which one we are converting? That one. Molar mass of A. So what is the molar mass unit? Gram per mole. What is the unit for mass? That is gram. So from this mole, we can convert into which one? Number of entities. Number of entities. In case entity is given, then we have to convert like this towards the amount. In case amount given means we have to convert toward the number of entities. So for this conversion, what is required? Avogadro number required. Na Avogadro number required. So Avogadro number is what is the unit? Number of entities per mole. Then in case reactant information is given mean what we have to do now? Use the molar ratio. Molar ratio. This is come from which one? Balanced equation. Then we can write here amount. Amount meaning what is that I told? Mole of B substance. Then by using molar ratio we can find out the amount of B. From this B, in case they are asking maybe mass, meaning we can convert mass. Mass in gram of which one substance? Substance B. For this conversion, what is required? I told you that molar mass. This is called molar mass of which one substance? That is B. Of B substance, that is in gram per mole. Then from this we can convert into number of entities or number of entity to amount also. So here number of entities. Which entities? This is number of entities of B substance. Here which one? That is A substance. So now to convert amount to number of entities, what is required? I told you that Avogadro number required. Avogadro number unit, what is that? Entities per mole. Of which one substance? Number of entities. Avogadro number of entities belongs to which one? B substance. So this is a hint for calculation of any stoichiometric calculation. So keep in mind, this is a very important. Look like maybe the simple thing, but this is the most important thing to calculate from reactant to product or product to reactant, mass to mole, mole to entities, or moles of substance to moles of substance B, or mass of substance A to mass of substance B, or mass of substance A to number of entities of B, or number of entities of A to number of entities of B, or number of entities of A to mass of B. Like this, any type of calculation, this is useful. For example, what is given here? I want to write one equation C3H8 plus oxygen convert into carbon dioxide plus H2O. This is generally liquid, this is gas, this is gas, this is also gas form. Then first we have to balance the equation from the previous video. You just remember the point. Start from the first point. What is the statement convert into equation? After that, balancing the atom. Balancing atoms start from which one? Complex, which has a more number of different atoms. So here first one C3H8 has a more number of atoms. Therefore, how many carbon atoms are there? 3 carbon left side mean right side are 3 carbon. Hydrogens are left side 8 are there mean here 4 into 2 8. That is right side 8 balance. Now oxygen balancing from the right side 3 into 2 how much? This is 6. This is how much? 4. Then 4 plus 6 how much? 10 mean 5 into 2 how much? 10. This is a balanced equation. Now, first one is microscopic level or molecular level. Microscopic level, or simply it is called molecular level. In molecular level, I will say this is 1C3 or 1C3H8 molecule. So this balanced equation indicate both molecule respective atomic level or molecular level or mole respective also. First one I am dealing about the molecular level. Next one is a mole level. So now this one C3H8 molecule and 5 oxygen molecules. Then 3 carbon dioxide molecule. 4 water molecule. Now in their mass in single one C3H8, it means 3 carbon. We have carbon atomic mass 12, then 3 into 12, that is 36, 36 plus 8, then it has 44, 44 unified mass this is. Then here oxygen is 32 into 5, then that is how much? 160. So each molecule is 32, 5 into 32 molecule, that is called 160 unified mass. Next here 3 into 44, then 3 into 44 how much? 132 unified mass. Next here 4 into 18. Water molecule how much? 18. So 4 into 18. This has 72 unified mass. These are molecular level. Next one, mole or macroscopic level. This is, I will use another color. So macroscopic level, little higher, this is called mole level, because this balanced equation indicate both molecular or mole level. Therefore this is called 1 mole C3H8, 5 mole oxygen molecule and 3 mole CO2 molecule, 4 mole water molecule. Now 1 mole C3H8 molar mass is now 44 gram. In moles it convert into gram. So this is the mass. So mass of 1 C3H8 is 44 gram, and this 5 moles of O2 is 160 gram, and this is 132 grams, 72 grams. Now you keep in mind, now reactant mass is equal to product mass. Then now 44 plus 160, that is 204 gram, that equal to, right side also should be same record, we'll try 132 plus 72, that equal to 204 gram. So we know the law of mass of conservation. So according to this is balance. Now you keep in mind, maybe molecule mean molecule level consider, mole mean mole level consider. According to this equation, now keep in mind molar ratio level meaning. Keep in mind, this is very important now. 1 mole or 1 molecule consider. So 1C3H8 is equivalent to 5 oxygen. Next, 1C3H8 is equivalent to 3CO2. Now it may be molecule or mole. Next, 1C3H8 is equivalent to 4H2O. Similarly, 5 oxygen is equivalent to, already it is reverse 1C3H8, otherwise equivalent to 3CO2. Similarly, 5 oxygen is equivalent to 4H2O. Similarly, 3CO2 is equivalent to 4H2O. Based on this, we can calculate. For example, now 1C3H8 is equivalent to which one? 5O2. Therefore, we can use a conversion factor. We can use the conversion factor is 1C3H8 by 5O2, or we can use 5O2 by 1C3H8. Like this, another one, whatever the equivalent, that also we can use. Based on this, calculation part will be easy. So like this, now for example, consider 2 moles of A gives rise to 3 moles of B. And according to the question, in question this may be given in the any amount, maybe mass given or moles given or number of entities. For example, mass given, mass of A given and mass of B given. Then we have to calculate the entities are like this. But first one may be only mass of A only given, and we have to calculate the mass of B consider. Then how to calculate this is mass respect you can calculate according to whatever I given 4 point respect also we can calculate. So now it is a balanced equation. Then mass given in what you have to convert first. First point is the balanced equation. Second point, what is that, convert into mole. Third point, what is that, from mole to what they are asking, mass. Therefore again use the conversion factor and convert into mass. This is a way, by using that, this mass how to get, by using the third point is called molar ratio. Now, so for that calculation, what you have to do is keep in mind, given mass converted to moles mean that is number of moles of A by its stoichiometric coefficient, that equal to number of moles of B by its stoichiometric coefficient. By using this formula, we can easily calculate the any given question. Always you can't remember the point, that's why use this one rank shortcut for calculation. Now a b given, now maybe in the equation any other is there, that also we can use. So I will use this one and I will calculate some questions. Generally calculations are, one is conversion mole to mole, second one is mole to mass or mass to mole, anyone reverse also. Then third one mass to mass calculation. Fourth one generally mass to number. Number meaning what is it? Number of entities that may be atoms or molecules or ions, anything like this. Sometime volume also, volume related question will get. Now the given question is, how many moles of NH3 can be produced from 5 mole of H2? Then first point what you have to do, write the balanced equation. So now nitrogen plus hydrogen gives rise NH3. Balanced equation is here 3 mole, here 2 mole, means this is a balanced equation. Then second point what is that? What they given now? Given is 5 moles of hydrogen. So this is 5 mole is given. Then they are asking this is how much. Then we have to consider this nitrogen is sufficiently react with the hydrogen. This is an assumption, otherwise we can't calculate, because if it's information given, that time we have to decide the which is limiting reagent. Now we are thinking that nitrogen also sufficiently react with the hydrogen. It means 3 moles of hydrogen react means 1 mole of nitrogen react according to balanced equation here. So 5 mole respect to nitrogen also react, consider, keep in mind that is. Then now what is the amount of this ammonia? Then what I told you that use the formula. What is the formula? Na by stoichiometric coefficient is equal to Nb by stoichiometric coefficient. So this is given mole. Then I have to calculate this molar ratio respective 5 mole by stoichiometric coefficient A, that equal to, and how many moles of that is ammonia, then we don't know, that's why ammonia stoichiometric coefficient how much, 2. Then these are cross multiplied here, therefore 5 into 2 divided by 3, that equal to number of moles of ammonia. This can be calculated as, after cancelling, you will get here 3.33 mole of ammonia. That is the number of moles of ammonia. This is a very simplest way. Anyway, here we no need to calculate mass or number of entities, direct mole only given, that's why this is the answer. Number of moles of ammonia is 3.3 mole produced. Next question is, how many moles of NH3 can be produced from 33.6 gram of N2? So what we have to do, the first thing is balanced equation. N2 plus 3H2 gives rise to NH3. This is a balanced equation. Now they are asking how many moles, but given is which one? Mass. Therefore keep in mind mass is convert into which one? Mole. Mole is convert into this mole of which one? This is N2. Then we have to convert into which one? Mole of NH3. Then what is required here? Molar ratio is required here. Then here what is required? Molar mass is required. That is keep in mind. So here molar ratio required. Here which one? Molar mass required. So the first thing what I am doing is nitrogen is given 33.6 gram and they are asking the ammonia moles. So how many moles of ammonia? Then what? This is the first point. Then second point is convert into mass to mole. Then how to convert mole? Mole is equal to mass by molar mass, that is 33.6 gram divided by molar mass of nitrogen is 28 gram per mole. In case not cancel, like this also keep, no problem. Then this is a mole. So mole of which one? This is nitrogen. Then what we have to use now? Stoichiometry, what do you call, molar ratio. So now N, number of moles of N2 by stoichiometric coefficient is equal to number of moles of NH3 by its stoichiometric coefficient. So now third point, by using molar ratio I am doing, this is a moles. 33.6 gram cancelling, mole inverse goes, this is nothing but mole. So now this gram cancel, mole inverse in numerator going to mole by 28. Then this is a mole. Stoichiometric coefficient, how much is there? 1 is there, that's 1. Next, stoichiometric coefficient of this, first I will equalize. Equal number of moles of ammonia divided by its stoichiometric coefficient, this one. Then what we have to do, this can be written as cross multiplied 33.6 mole divided by 28 and multiply with the 2, that equal to number of moles of ammonia. Then this will be cancelled, 2 ones are 2, 14s are. Then after dividing with the this 14, this may get the 2.40 mole is there. Therefore, number of moles of ammonia that equal to 2.40 mole. This is the answer. The next question is, what mass of hydrogen is needed to produce the 119 gram of NH3? Now, the first thing what we have to do, the first point is N2 plus 3H2 gives rise to 2NH3. This is a balanced equation. So what they given here, 119 gram 119 gram of ammonia they given. This is nothing but which one? Mass. Now what they are asking, what mass of hydrogen, how much? Then keep in mind, first mass is given, mass of which one? Ammonia given, that will be converted into which one? Moles of ammonia. For this what is required? Molar mass of ammonia required. Then this will be converted into which one? Moles of hydrogen by using molar ratio. Molar ratio. Molar ratio to, again we have to convert mass of hydrogen. For this what is required? Molar mass of hydrogen required. This is a path how to calculate this given question. So now keep in mind, first I am converting the moles of which one? Ammonia. So moles of ammonia, what is that? N is equal to mass by molar mass. Mass is given 119 gram divided by molar mass is 17 gram per mole. So this gram cancel, I am writing as it is next. So now I don't want to cancel immediately now, as it is I will keep, that is a mole. Then we have to use which one? I told you that molar ratio. In this molar ratio, what I can do, number of moles of ammonia divided by its stoichiometric coefficient is equal to number of moles of hydrogen divided by its stoichiometric coefficient by using the rank shortcut. Then in this one, second step, first one, number of moles of hydrogen by stoichiometric coefficient 3 is equal to number of moles of ammonia is 109, sorry, not gram, 9 divided by 17. This is which one? Mole inverse converted to mole. By its stoichiometric coefficient. How much stoichiometric coefficient is 2. So this is this ratio, molar ratio. Now we have to calculate the number of moles of hydrogen. Therefore, this 3 will be cross multiply 119 mole into 3 divided by 17 into 2. Then what we will get here? Now we got the moles. Still our question is not completed, that answer, because what mass of hydrogen hydrogen is required to produce the 119 gram of ammonia. Now we got mole, then what we have to do to get the mass? We have to do multiply the number of moles with the molar mass of which one? Hydrogen. So next one is mass of hydrogen, that equal to, what is it? This is the moles of hydrogen. Moles of hydrogen into molar mass of hydrogen. Therefore, moles of hydrogen is 119 mole into 3 divided by 17 into 2, and this is multiplied with the molar mass 2 gram per mole. Then mole inverse mole cancel, and after this all calculation you will get the 21.1 gram of hydrogen needed to produce the 119 gram of ammonia. Like this we have to calculate. Now, given question is how many molecules of nitrogen are needed to react with the 17 gram of hydrogen. So what we have to do, the first point is write the balanced equation N2 plus 3H2 gives rise to NH3. This is a balanced equation. Then we have to uh, take one path how to calculate this. First one, what they given, you have to check how many how many molecules of nitrogen are needed to react with the 17 gram of hydrogen. So now they given mass of hydrogen they given, then we have to convert into moles of which one? Hydrogen. It means N of hydrogen. Now from this, what we can convert by using molar ratio, then we can convert to moles of nitrogen. So mass to mole, what we can use? Molar mass of hydrogen. Then moles to another one substance, moles mean we have to use molar ratio. So by using this molar ratio, so N number of moles of hydrogen to number of moles of nitrogen we can convert. From number of moles of nitrogen to we can convert number of nitrogen molecule. Then how to get this is by using Avogadro number of which one? That is nitrogen. Keep in mind. This is a pathway to calculate this question. Then each one. First what you have to do, what is given, note down. Given is which one? 17 gram of hydrogen. So mass is given 17 gram. From this what we have to convert? This is how much they are asking in the molecules. So first we have to convert into moles. Moles equal to what is the mass by molar mass. Mass is how much? 17 gram. Divided by hydrogen how much? Molar mass 2 gram per mole. So gram cancel. So we have this a mole. Mole inverse convert to mole in the numerator. So we got the mole. Then what to do now? Number of moles of nitrogen by stoichiometric coefficient is equal to number of moles of hydrogen by stoichiometric coefficient. This is second step. Then by using this we can convert. We have number of moles of nitrogen divided by stoichiometric coefficient 1 is equal to number of moles of hydrogen is 17 by 2 by stoichiometric coefficient is 3. Then use the here unit mole because this mole inverse converted to mole. Then we got the now number of moles of nitrogen is equal to 17 by 2 into 3, that is 6. Otherwise you can add 2 into 3 also, no problem, in the mole. So now we got the mole about the nitrogen. From this what we can convert? Now we can convert into what they are asking, because now we have to calculate the number of what you call molecules. Then we know that N is, it means moles, is equal to number of entities by Avogadro number 6.022 into 10 power 23 entities per mole. So now we got the mole mean. What we have to do? These two will be multiplied. Therefore, I am multiplying this 6.022 into 10 power 23 N2 molecule. Entities mean here what is that? N2 molecule. N2 molecule divided by mole. So this mole cancel after multiplying and dividing. So what you will get here? Answer is 1.69 into 10 power 24 nitrogen molecule. I hope you understood how to convert from one given information to another, what they are asking, from one substance to another substance. This is a very simplest way to calculate any given problem, but keep in mind what are the steps needed and how to convert by using the rank shortcuts.